Welcome to Maths with Dan, and today we're going to look over a few sort of questions you get with speed, distance, time graphs, how to interpret it, what it means at certain points, and then going over some questions that you can get from online. And if you enjoyed the video, leave it a like. And if you want private tutoring lessons, just email the email in the description below and leave any comments if you don't really understand anything, and enjoy the rest of the video. Thank you. So starting off with question 1, we have Rebecca went on a bike ride. This graph shows Rebecca's distance from her home on her bike ride. How far has Rebecca travelled for the first 30 minutes? So in a speed, distance, time graph, we have distance on the left, time on the bottom. So how far has Rebecca travelled after 30 minutes? You go along to 30 on the time, then you then go across, and you can see that's 6. So she's travelled 6 kilometres in that time. The next question is, after 60 minutes, Rebecca stopped for a rest. So you can see here, for how many minutes did she rest? So a rest on a speed, distance, time graph is seen when the distance isn't moving anymore, but the time is still increasing. So you can go up and you can see there's a section here where the distance is no longer moving, but the time is still moving because she isn't moving anymore, but she's resting. And you can see that the distance in that time is that block and that block. So there's 2 block distance in that time. And you can see there's 3 squares between 90 and 60. So 3 squares indicates 30 minutes. So 1 square indicates 10 minutes. And the distance is 2 squares. So 10 times 2 is 20 minutes. So she was on rest for 20 minutes, I believe. Give you guys a second just to see that and look over that. 2 blocks, 20 minutes. How far did she travel in total? So you can put that 10, 10. Each block is 10. So in total, she travelled, you can see up at the top here, to get a distance, it was 12 kilometres there and 12 kilometres back. So 12 plus 12 is 24. Now, next question. Emily drove to the beach. She stayed at the beach and then drove back home. Here's Emily travels graph. So you can see she's travelling to the beach. She's then at the beach. Now she's coming home from the beach. For how many minutes did Emily stay at the beach? So it was a time when she wasn't travelling, but the time was still happening. So it's the difference between that time. It's about 2:45 and 4 o'clock. So the distance travels at 2:45, 3:45, 4:45, minus 45 minutes. Just working it out. That should be, I believe, 75 minutes. 2.5, 3.5, 4.5. Yes. Because you have 15 plus 30 plus 30, which is 75 minutes. So you have 15 between the first line and 3 o'clock, 30 minutes between 3 o'clock and 3:30, and another 30 minutes between 3:30 and 4. See this next question. Dawn drove from London to Birmingham. She made up 1 stop at the service station. You can see that straight line there is the service station. For how many minutes did Dawn stop at the service station? So remember, when it stops, that is basically the straight line part because the distance isn't moving, but this time is still increasing. You can see that is that little distance there. So there's 3 blocks between 11, 1, 2, 3. 3 blocks between 11 and 12, so each block is 20 minutes. 20 times 2, that's 40 minutes. What was Devon's average speed between London and the service station? So see, London to the service station. Speed is distance divided by time. So you do from London to the service station, which is when she stops, the distance is 60 kilometers, and the time it took is that's 1 hour, 10 to 11, and that's in a third of an hour. So 1 and a third, so it's 1.33. So distance is 60 divided by 1.33. Should then give you, I believe, 45 miles per hour, depending on how you put it in the calculator, should round to 45. Next question. Birmingham is 120 miles away from London. Dawn arrived in Birmingham at 2 o'clock. So you go to 120 distance up to 2 o'clock. Just making sure I've got the right one. This is just plotting on the graph. And then it then should be a straight line. I find it quite hard to draw a straight line on this, but this should be a straight line. Because speed, time, distance graphs are all straight. It's one of the rules. And now this is like a real life sort of example. This is a proper one you'll get in an exam. A horse and rider takes part in a long distance race. The graph shows how far and the horse rider went during the race. The first question is, what was the distance of the race? So you can see the distance of the race. F is the finish line, and if you go across, it's 60. So distance is 60 kilometers. How long did it take for the horse and the rider to complete the race? So finish line, you go down to the bottom. That took 5.5 hours. So 5.5 hours, or you say 5 hours 30 minutes. You just need to make sure in an exam sort of situation you specify the units. You couldn't just say 5.5 because 5.5 what? It could be 5.5 horses, 5.5 cups of water. Make sure it's 5.5 hours. Next one, what was the distance the horse and rider travelled in the first 2 hours of the race? So you go time, you go to 2 hours, then you go across. This is reading from a graph. That's 30 kilometers. How long do they stop during the race? So you can see that's when the straight line part, that's the bit when the distance isn't increasing anymore, but the time is. See, that's between B and C. You go down, difference between 2.5 and 3 is 0.5, so that's half an hour, either 30 minutes or 0.5 hours. And that is it for today. I hope you enjoyed, and see you in the next video.